This is Corey Willis with PPI, and you're listening to the Diesel Podcast.
I'm Adam Blattenberg from Diesel World.
Hi, this is Dan, owner of Dan's Diesel Performance.
I'm Christian Roth of BD Diesel.
I'm Braden Fleece, and you're listening to the Diesel Podcast.
What is going on, Diesel Nation? We're excited to have you guys with us today on the Diesel Podcast. If you're listening on one of the podcast apps out there, we encourage you guys to go to YouTube, search the Diesel Podcast, and subscribe. There's extra content and also really cool discussions that people have on our episodes. So if you're looking for a bit more than what we have on our weekly shows, make sure you subscribe on YouTube and you'll find it right there. Before we get to today's episode, we want to give a shout out to one of our sponsors, which is Mishimoto. And we've had them on the podcast before talking about cooling products and transmission coolers, intercoolers that are specific for vehicles, and then also ones that are universal. So if you have a custom project where you need to get some extra cooling capacity, they have a ton of different things and also other products as well. Just go to mishimoto.com, check out what they have. You can search for products specific to your Cummins, Duramax, or Power Stroke, or universal products as well. If it's something of a custom project or a swap or something like that, they've got something for you. If you're a shop owner, you're looking to purchase Mishimoto products, just search Turn 14 Distribution on any search engine. You'll pull them right up. Give them a call if you're not set up. They'll get you over to one of their diesel representatives. Make sure you get taken care of. And their website is super easy to use and navigate. So if time is of the essence, you can go right on their website, see what's in stock, where it's in stock, how quickly you can get it, and make the whole process easy. On today's episode, we're going to be chatting with Cass from Choate Engineering, and he had mentioned that one of the most common questions that he gets is about rotating assembly failures, whether it's a Cummins, Duramax, or Power Stroke. And he wanted to talk to us and our audience about bearings and different things that can affect bearing failure. And it's going to be a really in-depth conversation and a lot of different things that go into it. So we're looking forward to chatting with him today. All right, let's get to the podcast with Cass and chatting about rotating assembly failures on diesel engines. Cass, welcome to the Diesel Podcast. We're always look forward to chatting with you about engines because that's really the heart of the podcast. Is we're talking about diesel trucks and diesel engines. And before we sat down today, we were chatting a little bit about what's a topic that we haven't really gone in depth with, and lower engine failures is one of them. And there's a lot of really great information and insight that you have, not just for a truck owner out there that may have some questions, but also for the professionals, the shop owners that are out there, the machine shops that where they can help the customer or create a happy or repeat customer with some of the information you have. So I'm looking forward to chatting with you today, learning more, asking you some questions along the way, and making sure we get some great content out there for our audience.
Well, thanks for having us. As always, we enjoy coming on and talking about our passion, which is definitely engines, and getting more into the technical side of things instead of just talk. Anytime we can talk diesel engines and talk the theory behind them, that's always a good day.
When I think of lower engine failures, my first thought is always, a connecting rod let go and there's a window in the side of the block. But there's so much more to it than that, and I'm ignorant of much of it. But I definitely want to learn more about what kind of failures there are, or issues, or things, or just things that people are calling in on a weekly basis asking you guys for information on, or for a fix or more insight.
Yeah, I mean, there's a lot of things that are very self-explanatory as far as maybe what a failure. The guy ghetto fogs an engine and blows it up. That's pretty. Sean Bach's explosion with the nitrous the other day, where they're picking up pieces of the engine in outer space. I mean, obviously, we know, when you're pushing an engine to the amount of extreme pressures that they are to make those kind of numbers, it's pretty easy to tell what caused the failure, or too much skinny pedal. It's just, some of that stuff is pretty cut and dry. But the harder things to determine sometimes or what causes the failure when everything seemed to be going good,
Right.
I'm just driving down the road, and then next thing I know, I'm on the side of the road, and the engine's smoking. I pull the dipstick, smoke's coming out of this, this thing. What happened, So those are a little bit more difficult to figure out.
What are some of the issues that you're going to find on the lower part of an engine when we're talking about failures like that, where it's maybe not as obvious?
Yeah. Well, obviously there's a lot of things that can cause lower bearing failure, and there's a lot of topics to discuss just about the bearing failures maybe that may be seen, which might be anything from lack of oiling to contamination to high oil temperatures, poor cooling systems. There's a tremendous amount of subject content to discuss about that. But I guess I'll try to narrow that down a little bit today and kind of talk about one particular type of failure, because there's this one type of failure on the engine that has to do with the thrust bearing that is probably the most dreaded failure. It is one of those things that there's so many different things that can actually cause it to fail that sometimes it's a little bit difficult to pinpoint. And some of it can be on the machine shop. Some of it can be, and this is where it really gets kind of hairy, is because sometimes it can be the machine shop. Sometimes it can be the transmission torque converter. Sometimes it can be the guy that installed the engine. Sometimes it can be fuel that that got into the crankcase that causes failure. Sometimes it can be the guy that's, in some cases, even the guy that's driving it that's riding the clutch. On a high performance clutch, there's a lot of axial load that's placed on that to make sure that clutch doesn't slip. And there's a lot of forces that are applied. When we talk about axial load, we're talking about the force that's applied on the crankshaft through the center line axis of the crank, from aft to forward. So if you can take, if we were taking the crankshaft and we were on the backside of the engine, and we're trying to force that crank by pushing on the flywheel and try to force it out the front of the engine, that's what we're considering when we're talking about axial load. More radial load or dynamic load for downward forces, where you'll see on higher cylinder pressures, things of that nature. Those type bearing failures are not as difficult, I don't think, in my opinion. They're not as difficult to diagnose, typically because if you get too high engine loads, we start seeing, like I said, window blocks. It just depends on the rods that are in the engine. If you get a guy that's got a 7.3 and he's putting a lot of power to it and he's still running a powdered metal rod, or even a forged rod that's factory, and he blows a rod out the side, it's very typical or indicative of cylinder pressures that you are overstressing the connecting rod. But when we're talking about the thrust bearing failure, things people need to understand is, what is the thrust bearing, right? What does it do? What's its purpose in life? And what's its greatest adversary that it's really fighting against the whole time? And when you start thinking of that, you might have a little bit of sympathy toward the whole thing, because on the some engines are better endowed with thrust bearings than other engines, and that's basically a direct reflection of what the surface area is for that. A smaller thrust bearing does not allow for, with a smaller area like that, it just does not have as much bearing support in that area there, and it can lead to problems. So thrust bearing, what its job is to, just like we said, we're making sure that the crankshaft doesn't move fore or aft. If it does, I've seen crankshafts, I remember many years ago, it's not something you see a whole lot of. Generally, if you see a lot of thrust play like this on an engine that's, obviously on an engine that's been rebuilt, there's something going on. The builder, the crank grinder, they screwed up somewhere. I was at the Ford dealership picking up parts or something. This has probably been 10 or 12 years ago, and I was talking to a friend of mine while I was there. They'd installed a Ford rear main engine, and while they were there, said, "Man, this is the third time this thing's been here for a rear main seal leak, and it's only got like 3,000 miles on this thing." and they couldn't figure out why in the world this thing just will not quit leaking oil. They keep replacing seal, and and they'd send it out, and it would come right back. But the reason why it was because the in-shaft play was too great. And in-shaft play, it plays a huge role in transmission building. It plays a huge role in anything with axial thrust or load. And an engine is definitely one of those things. So when you're building an engine, one of the main specifications, they're all important, but this is one that you don't want to leave out. And most people never measure it because they don't have the proper tools to measure it. You'll need something like an axial indicator that you can put on the flange of the crankshaft and force it forward, zero it out, and then move the crank the other direction and see actually how much in-shaft play that you have. It's really important to make sure that you have the correct amount of in-shaft play. Without enough in-shaft play, there's no room for the oil to get between the thrust face and the journal of the crankshaft, or the face journal for the thrust area. And that's typically, you'll see, the spec can range pretty broad, 3 to 18 thousandths, but if you're seeing something that high, typically the target range is 3 to 8 thousandths. And I don't like to see anything really over 8 thousandths range. I want to be right between 3 and 8 is what I'm shooting for. And that's pretty well straight across the board. I don't really have a lot of, it doesn't vary too much from engine to engine. But there's a lot of things that will cause that failure. So it's extremely important. It's something that I have learned in this business, people don't realize. As a consumer, you think, and I'm guilty of this, you think that you bought a new part and the part you bought is good because it's a new part.
Yeah.
That's going to cause you a lot of problems. You and I were talking about this right before we went on, how many guys build their own engine, and what's the difference between the guy building the engine necessarily in the garage or the guy that is building the engine that's a professional engine builder, not an engine assembler? There's a big difference. I've made some other guys in this business mad because I made a distinction between, and I read somewhere back in guys like Smokey Unick, and he had the same philosophy. There's a big difference between an engine builder and an engine assembler. The engine assembler works with the content that he has. He grabs the bearings, he grabs the parts, and he installs them in the engine. The engine builder is the guy that actually sets up the tolerances. He's the guy that actually changes the dynamics of the engine. He's the guy that actually can dial this thing in. But an assembler is no more than, somebody on the assembly line that's just slapping bearings in. And unless a guy really knows his stuff and has the proper wherewithal to measure and knows what to measure, I'll tell you, a good friend of mine, y'all had him on the podcast, and it was from Comp Cams, Billy Gobble. It was funny because they were talking about they have a machine that they use to check the surface finishes of the crankshaft. And anyways, he said, we sent out crankshafts for years and years and years, and I think each one of these pieces of equipment were $350,000 to $400,000 or something. Don't quote me on that, but it's extremely expensive. Whatever it was extremely expensive. And anyway, he said for 3 days we never sent a camshaft out because we were so terrified. Now, they've been sending camshafts out for years and years and never thought anything about it. The more you learn, the more you know, the more scared you get about stuff, and the more conscientious you get. The guy that really sleeps the best at night sometimes is the biggest idiot of them all because he doesn't have any more sense than to be worried. Because everything's hunky-dory to him. He just doesn't know. Everything's good, It's kind of like the guy that doesn't check his bank account. He never worries about his finances, right? It doesn't mean that his finances are good. It's just he's not worried about them. And, it reminds me of a guy said, he said, man, I know you've got financial problems. He said, you seem really calm. What you do? He said, man, I hired a worrier. He said, man, you were $3 million in debt. How in the world did you afford to pay a worrier? He goes, I don't know. That's his worry. So, it kind of boils down to the more you learn, the more you know. And a good, really, really, really good friend who's taught me a tremendous amount. And if you're in the engine building business, you know the guy that I'm fixing to mention. His name's Chuck Lynch. The guy's a brain, and I mean, he's just super, super good guy. I mean, I love him like a brother, but he's taught me more about things, engine-related things than I ever considered. I was happily ignorant of, you know, and then he's like, well, what about this? I'm like, oh, man, are you serious? I hadn't even thought about that, but you're right. That would change the whole dynamic. But again, going back, I digress, but going back to the guy building in the garage, most of the time you grab these parts right out of the box. I could name some suppliers. I'm not going to, but I want you to believe me when I tell you this, that we have tools set up that we've machined and we've made so that we can, what we call it is qualifying a part. And it doesn't matter, it's a brand new part, but we have to qualify that part because what we're dealing with is not just this is not, like I tell people all the time, we're not making hamburgers here. If we screw this up, this is thousands and thousands of dollars. We can't afford to think we're right. We have to know we're right. And because of that, a lot of times I will design tools just for the shop for us so that we can verify the quality of the part, the crush value, for instance, of the bearing. Like you grab a bearing out of a box, you slap it in there, you tighten it down, you torque it to spec, and you go, okay, great, the bearing's going to stay. Well, let me ask you a question. What if that bearing was not machined exactly the same? Because I'm going to tell you, they're subject to two things that really all manufacturers are subject to. One is people. People screw up every day, and they're the reason why the shuttle that launched, what was it, Apollo, that blew up. I mean, that's the O-rings that failed, right? You've got people there that it doesn't matter what line of work you're in, you're subject to failures from people, and you're also subject to failures from equipment. You know, you can set something up, you can move the machine may not that you're working with may not hold the same tolerance because of wear and tear on the machine or setup, fixturing, whatever it might be. So you have to make sure that you qualify that part, even if it's a brand new part. So what if we had a bearing that didn't have the same crush value and it spun? What I mean is you know, when you put a bearing in the bottom end of a block, there's a certain amount of that bearing that actually overhangs. It doesn't go all the way. If you've got a main cap that goes into the saddle area and you tighten it down, there has to be a little bit of that bearing that sticks up. That little factor there is the crush factor. That's actually, and it's a huge misconception that the bearing actually stays in place because of a tang. The tang has nothing to do with it. And I've heard other engine sellers in this business that would tell you that 6, 7 failures because of the tang. It has nothing to do with it. They don't even have a tang on them. It's just there for placement. It makes it a little bit more convenient to place the bearing. What keeps the bearing in place is that crush factor. But if that manufacturer doesn't machine that or doesn't manufacture that bearing to the right geometry, then you have lost some of that crush factor. And as an engine builder, it doesn't matter what the manufacturer does. The great thing that the manufacturer's got going for him is he can just say, here, let me send you another bearing. Well, it just took this dude's engine out right now. He's hot. I mean, obviously so. I can't just go, you know what? Yeah, we'll just send you another bearing. It doesn't work that way. You know, it's like a guy with an injector failure that blows the engine up. I'm so sorry, Mr. Jones. You know, we know we took your engine out. Let us send you a brand new injector for that number 6 hole. You know, doesn't do me a lot of good. How about you send another engine with that number 6 injector that just blew up? You know, the engine when the nozzle fell off or whatever happened. So it's important to qualify that. So as I'm digressing, I want to make sure that people understand, though, getting back to the thrust bearing issue, it's extremely critical. It's a small bearing that has a lot to do. It's very, very much a precision item, and there's a lot going on with that bearing, and there's a lot of things that can cause failure. Now, as far as the installer standpoint, a guy that's just, you know, what can I do to make sure I'm doing it right? Most people will never do this. Most engine builders or the guys that are doing it in the garage, they don't know to do this. But it's extremely important when you're installing that thrust bearing that that before you torque that bed plate down or that main cap down or whatever, you know, that when you got to torque the bottom end down, most guys don't know to preload the axial thrust on that bearing. So you should be forcing that crankshaft forward to seat the bearing. If you're not doing that, then you can actually tighten it, and it will remain in a place that will cause it to take up some clearance, and it will cause it to wipe that bearing out prematurely. And you'll have premature failure simply because before you torque this thing down, you should have had some way to force that crankshaft in forward, moving it like you were trying to push it out the front of the block, right? And I saw where Jeremy made something the other day, Jeremy Wacker, for the Duramax. He's got a little plate that he uses, and it's a good idea. It makes it easy so one guy can do it, but he can also put a certain torque spec on it. But anyways, it sets the axial preload for the crankshaft when you go to install the bearing, which is a great idea. It's a very good idea. And let me tell you this: it's not we don't make these things because we think we're going to be, we got nothing else to do. No, if you see us make something as an engine builder, it's because it's cost us money. It's because we don't want this headache. We don't want you to have this headache. And we're not just trying to generate another product to sell. No, these are things that we actually use because there's a definite need for it, and that's the proper way to do it. So it takes us longer to do this too. I mean, when we're installing these parts in an engine, we're doing it this way because we know it is absolutely necessary. So when you're doing with thrust bearing failures, things like this, there's a lot of things we said that can cause a failure. If you've got any questions, jump in at any time because I can talk for forever.
Well, I was thinking with these failures, let's just say if we take core engines that you get in, and would this be a large percentage of issues you see, regardless of what kind of engine it is? Is it bearing failure?
Certain engines are more prone to bearing failure for sure, and I think we covered that on 6.7 Power Stroke episode. 6.7 Power Stroke episode definitely has more bearing failure, and I've got more people that have told me, "Oh, you're an idiot." I know you're saying is the oil, the thickness. We talked about viscosity, and the truth of the matter is where they might get away with it. Kudos to you, but I mean, I can see that I can show you 25 blocks right now that didn't get away with it to your one that that did, and there's a lot more that's involved with that. So thrust bearing failures are more prone to certain setups. Okay, for instance, a guy that's running a triple disc billet converter with high line pressure that's doing lock shifts and has a plugged cooler, he's going to be more apt to take out a thrust bearing for sure. A guy that's running a big 40-inch tire. I had a guy call me the other day, and I told you when we were talking about this, you name a part, I can give you multiple catastrophic failures, or I can give you horror stories on stuff from people that I've known or personal experiences with things. Because when you get this much experience with what you're doing, you've generally got like a library of stories. But this guy called me the other day, and he was starting to down one of my competitors. Man, this is the third engine I bought from this guy. And I'll tell you something I've gotten real careful about. When I was starting out in this business, I was really ignorant. I was, how you're anxious to get the customer's business. Okay, that's great. And, that's what you want. But generally when you are hearing this customer tell you something, you're trying to tell them what you can do for this solution or that. If the guy's had 3 failures right now, could it be a possible failure of that shop? Maybe they're doing something wrong. Yeah, absolutely. For sure it could be. I'm not saying that. But I'm also saying be swift to hear, slow to speak, slow to wrath kind of thing. There's a scripture in the Bible that says that. So I'm quick to listen, and then I try to process it. And before I go saying, well, that company this or that company that, I'm trying to go, wait a minute, hang on. Let's make sure you don't have a problem that you don't realize you have a problem with. And the guy tells me, man, I've had 3 thrust bearings out of this. This is the 3rd engine this company's built. Can you build me an engine? And as soon as they say that, I want to go, wait a minute. Yes, we definitely can, but I don't want to be in the same category. I don't want you to just keep, the definition of insanity, they say, is, doing the same thing over and over again and expecting a different result. If we're doing that, there is something that I wish people would understand. Stuff doesn't just break. I mean, there are circumstances, but there's always generally something underlying that causes this thing to break. I mean, I got a guy that called me this week. He's blown up 3 engines on a Cummins. This was on a 5.9 Cummins, and he keeps blowing holes through pistons. And he's frustrated. And it's not the casting of the piston. you've probably got something going on with an injector either that's sticking open or you've got injection timing issues. But you can't keep doing this or you're going to lose so much. We need to put a time out here and say, hang on, let's figure out what's going on with this. This is insane. You can't afford, you're going to be bankrupt at this rate. Let's stop and think about this, okay? There's a solution to the problem, but we need to figure out what the problem is. So as far as certain thrust bearings on certain setups, this guy that was calling me and telling me, this is the third engine that I had fail from this. Then I asked him one quick question. Is the truck lifted? And the guy goes, well, it's on 40-inch tires. Okay. And now everybody out there is listening. So, man, my buddy's got 38-inch tire on his, 40-inch tire on his. Yeah, never had it. I get it, okay? But there's something going on with that guy's setup. You got a 40-inch tire, you're spline locking, very good indication, the fact that you've toasted 3 engines, and they're all the same failure. It's not like you melted a piston on one and tore thrust bearing up. No. What we call that is a repeat offender, and you are having the same exact failure. But what's happening is he's spline locking the shaft on the converter because of the angle of inclination, and it's forcing that crankshaft. The crank has nowhere to go, and it's just, all it's doing is being forced into that thrust bearing, and it's eating the thrust bearing because there's no oil clearance that's being allowed for it anymore. So, you need to start looking at the setup. So there is some things that are more prone. Lifting trucks always, when you got guys, I'm not talking like leveling kits or stuff like that, but guys putting these big tires on stuff, generally those are the guys that are always the ones, talking about how they can't make transmissions live, and how they're having issues with other things. There's ways we can definitely do it, but you need to do it right. When a guy starts having failures like that and you realize, there's no dowels in the back of the engine when he lines the transmission up, and he's taking out pump bearing bushings in the trans, and he's taking out thrust bearings in the engine because there's no lineup dowels there anymore. Well, there's a reason why the manufacturer put that there. So it's important. You can do a lot of things to damage a perfectly good engine, and it had nothing to do with the guy that built the engine. It had nothing necessarily to do with the guy that built the transmission. It could be. But it could be the way that it was installed or the application that it's in. And then there are times that it can be absolutely the machine shop. Some things that need to be really considered, because I know of a lot of shops. This would terrify me because I've been in that position before. But I know a lot of shops that build their own engines. They think, okay, well, I'm going to build my own engine and I'll take it to the machine shop. I used to do that, take it to the machine shop years ago and let them do their thing, and I'd get it back from the machine shop and assemble the engine. And I think I told you a horror story before. I wish I could tell you a horror story on everything, but I had a guy, what got me in this business years ago was I had a 6.4, and anybody that's ever bought a Ford three-man 6.4, the chances of you having this type of block are like a 99.9% chance. There for a short time, they didn't actually use plasma weld technology, but if you look at their brochure, there's a brochure that they boast about it. But anyways, and that's a whole nother episode, a whole nother set of problems, and we may have discussed it before, but it doesn't hold up well. But anyways, the guy was trying to machine the block, and he called me, and he's like, man, every time I punch a hole through this block, it's like I thought it was oil in it, but this thing's smoking like crazy. And I said, okay, I'm not a machinist. What do we need to do? And he said, well, I think I'll have to sleeve every hole. Well, the reason why I was talking about that was because he didn't realize at that time that they used a spray weld technology or plasma weld technology or spray bore technology. These are all names that they use for spray welding the bore, and guys are going to say, well, yeah, they work fine for, they even use it in NASCAR applications. Yes, they do, but the application for a diesel is not the same. The cylinder temperatures are a lot higher. The adhesion to the wall is quite a bit different in the process, so we see a lot of delamination, and there's a lot of problems like that. But if you ever try to go bore that block back, it's going to smoke your insert, and it's going to smoke like a freight train. So I said, we'll do whatever it needs to be done. The guy goes, well, I can sleeve all 8. I said, I'll bring you another block if you need another block. No, I can make this work. Long story longer, he goes and puts 8 sleeves in. I start the truck up after I rebuilt this thing. He sucks the sleeve into the block because he didn't put a flange at the bottom. He didn't put a step there. and it sucked the sleeve right to the bottom, blew the block up. I didn't have 30 seconds on this block. And here I find myself tearing this thing back down. I've got a customer that's needing his truck, and I'm stuck in the middle because I trusted this machine shop to do his job right. Long story short, that particular time, they made it right, and they wound up getting me another block. But it was a big mess. The big thing that you really need to know, though, is you are putting your head in the noose, right? Your neck is in the noose as a shop owner, and you're going, okay, well, I can build this engine. Yes, you can, and you may be fantastic at what you do, and I'm not disputing, their experience there, and I because everybody's different. I don't know how many people are listening to this podcast, but there's things that people don't realize, and there's engine builders that have been doing it for 40 years that don't know some of this stuff, and the only reason why I've learned it is because either I had to learn it because it was an issue that we had, or because I had been fortunate enough to reach out and get involved in a network of people that were really, really professional at what they did, and they took me under their wing and they said, hey, these are things you need to be looking at. One of the big things that you need to look at that will cause failure of the thrust bearing is what I call the windshield wiper effect. What that is there's a starburst pattern excuse me, on the crankshaft itself, okay, a sunburst pattern. If you look at the thrust face of that, and if you've looked at many of them, some of you guys out there, go check out your crankshafts that are laying over there in the corner and look at the thrust face. What I'm talking about looks like it's like you were to spin a light and it just kind of, it expands outward. It's like I said, it's like a starburst or sunburst pattern. And it's where it looks like a centrifugal force just kind of flings out these marks. And what happens is those marks will act like a windshield wiper. As it goes around, they actually wipe the oil away from the thrust bearing and starve it for oil. And there's a couple of reasons why that's that way. You don't want that. That's bad. That will definitely take out thrust bearing prematurely. Sometimes it happens because the crank grinder does what we call bump grinding. And bump grinding is, and I know that I'm kind of probably talking stuff that's maybe not the hearers or the listeners' forte, but anyway, when you're grinding a crankshaft, right, you're spinning this thing, just think of kind of like a lathe, for the lack of a better term, but it's got a headstock, tailstock, and you got this big grinding wheel, and you go in and you're rotating this thing along the center line of the axis, and you're making sure it's concentric and everything, and you're coming in and you're grinding. Well, when you grind, you plunge grind. You don't, if you move over too far to that face gets actually ground on the side of the wheel, and it can generate that starburst pattern. And I've seen it from the factory too. I've seen more of them probably from the factory than I have that I can tell you. But anyways, that can definitely cause a premature failure of the thrust bearing because it's wiping that oil away. Another thing is the improper thrust face surface finish is another thing. If you really want to do this, you want to get good at it, you need to invest in some good equipment that can, this thing's, what I'm fixing to tell you is just a small tool that we use every day. It's a couple $1,000s. You can get like an SJ, like an SJ 280, I think, a Meditoya, but it's a profilometer. I forget what the model number is on it, but they have different ones. But anyways, we use a profilometer that measures the surface finish. The surface finish is going to tell you what is going on there's a certain amount of retention, just like a cylinder wall, that there's a certain amount of oil retention that needs to be on the cylinder wall so it doesn't wear the ring out, because it's a hydrodynamic wedge that's between the ring and the wall itself. So if you had metal-to-metal contact where the ring is coming in contact with the wall, it's going to prematurely wear your rings out. If you've got a really coarse, I don't know if we've talked about this before, I'm pretty sure we have, but if you've got a really coarse guy that's, a hone surface finish that you're leaving on the wall, it wears the rings out really, really fast. I can tell you a horror story on that on my machine shop before I got into this business. And, when you're sitting there idling, no smoke. You got to take off from the light. You got, blue smoke coming out. And anyways, it's wears rings out in 5 miles. But anyway, it's extremely important to know what that surface finish is. every static and dynamic surface of the engine has a surface. Anytime for instance, your head gasket, it has a surface finish. We'll use generally something like an RA finish. RA is an average roughness it's a mathematical average for the surface finish on whatever said surface that we're measuring. But it's a static measurement. What we don't, if it's a part that's not moving, I'll use an RA finish. Typically RA is not preferred, but on a static surface like a head gasket, it's not actually moving. Whereas a cylinder wall, where you have a piston that's going up and down, it's more of a dynamic surface that you're seeing something moving up and down. That's not the kind of finish that you want to go off of. And there's reasons why, and that can lead into a whole lot more confusion, and we don't want to get into that. But if you want to, you can do a little research on surface finishes. But we use RPKs, RVKs, RKs. All that is like, if you know anything about bolts, you've got a major diameter and a minor diameter of a bolt, right? And that's the thread pitch as it goes out. That's your major diameter. Your internal thread pitch of the bolt, or I say your internal, what I mean is your smallest area of crest would be your minor diameter. If you looked at the major diameter, you look at that as an RPK. If you looked at the minor diameter, you look at that as an RVK. If you looked at the difference between the two, which was the pitch diameter offset, that would be your RK. But anyways, the surface finish is extremely important. So you're looking at like a production engine of about a 10 RA. So you need to have some way to measure that. The last thing you want to do is get that engine together and wind up having premature failure. And so there's things like that. Another thing that is a big issue nobody talks about is thrust bearing parallelism, or perpendicularity, I should say. It's extremely important. If anybody's willing to endure to this part of the podcast, then they're going to learn a lot. But because it is important information. One of the things is the thrust journal. Right, if you look at the thrust journal on a crankshaft, you've got obviously where the bearing would come in contact when we're talking about the actual journal. Then you have the thrust face, whereas the shiny part on the, if you were looking on the Power Stroke engine, on most Power Strokes, it's going to be on the fourth journal. And different engines like maybe a 6.7 will be on the fifth, it'll be on the fifth journal. But that face on a Duramax, same thing. But, excuse me, on the face of that journal, that 90-degree relationship between the journal itself and the thrust face is extremely important, that there's perpendicularity to it. So it needs to be a 90-degree relationship. If you don't have a 90-degree and you kind of have an obtuse, angle there, what happens is you're losing some of the support that you would have from that bearing. It's not supporting that bearing anymore. It can also cause some of that oil that would stay in a relationship and create a hydrodynamic wedge now to no longer be able to support it because it's an obtuse angle. And that's extremely important. Another thing is parallelism between the upper and lower. In most cases for diesel applications like on a Duramax, you'll have an upper and a lower bearing, on a three-piece bearing. On a 6.7, Power Stroke, you'll have a same thing. It's just identical. Whereas on a 6.0 or 6.4 or 7.3, you have just that two-piece bearing, which also leads me to say one other thing. There's a lot of difference between the way the bearing is designed on a 6.7 Power Stroke or a Duramax versus like a flanged type bearing on a one-piece thrust bearing on maybe 6.0 or 6.4. Some of the guys may notice that the bearings actually look like they're, how do I put this? They're like they're a press fit. The flange itself presses into the main body, and they'll see them pop off like that, which has become a really big issue when you're not looking at that block. You've got to be really careful that you look at the block and make sure that the block is perpendicular to the housing bore and parallel to the opposing side of the block itself. It'd be a whole lot easier if I could draw a picture on this. But anyways, if it flares out that thrust bearing, it creates the same effect that we talked about with a surface that's not perpendicular, and it'll cause premature failure of the bearing itself. So those are the main causes as far as the engine builder needs to be concerned about. Then there, like I said, we talked about those failures that could be from the transmission issues. And then there's another type of failure that can cause it, and that's actually, I have seen this before, where you have poor grounding. And it's not so much of a problem with some engines as it is others. A good friend of mine worked with Zora Duntoff for years back in the 60s when Chevrolet was kind of underground about their racing team, development. And they spent the better part of a summer trying to determine what the thrust bearing failure causes were for the 454, big block Chevys and stuff like that. And what they found with it was that there was poor grounding. Right where the starter is, it was actually arcing through that block and causing the spot weld from the thrust bearing to the crankshaft journal itself. Who would ever thought that, It's just one of those things that you thought, there's no way that thing would actually use that block as a conduit and come out right against that crank, but it's a machine surface and it's nice and it makes, good contact right there. And stranger things, have happened, but that's just one of those things I never really would have thought about that. There's other things, as far as machine shop's concerned, we're really careful about if you grind the crankshaft a certain way or a certain rotation, that you polish it favorable. They call it, one's favorable, one's non-favorable, but one direction. If you're grinding the crankshaft and then you flip the crankshaft around, it's kind of like you parting your hair or rubbing a cat, one way. That metal actually lays down a certain way when it's ground. If you try to polish it back the other way, you're standing it back up. I know you don't look at metal like that because it's not as easy to manipulate as, something like maybe a fabric or hair or something like that, but it actually can have a effect on the surface finish. So if you grind favorable, you want to polish favorable, or vice versa, so that you make sure that you're doing it in the same way. These are things that probably are more of an issue with the diesel guys because, and they are definitely an issue with gas burner guys too, but a diesel engine will wreak havoc because of the amount of torque and also because of the amount. Now, if a guy's a high-performance gas burner guy, he's definitely in that same he's corralled in with the same problems. But guys running, like I said, these big clutches on their trucks with pressure plates that are a dual disc setup that is running a lot of clamping load, and you're doing this day in and day out. Most of the gas guys that are making big power, they're taking these things over the racetrack. The problem with diesel guys is that they make big power and they drive it to work every day. And that's a lot of wear and tear, so it has to be right. So you have to pay attention to some things that you could have gotten away with. If you don't believe that, like transmissions. I mean, it's a lot easier to take a gas burner transmission that doesn't have the same amount of torque that it's subjected to as a diesel transmission and make that live, whereas you won't get away with it if you got a guy that's got a lot of low-end torque on the Cummins. It's really brutally destroying these things. So those are some things for thrust bearing. I think that's probably as much as the poor populace that's listening to this can endure. There's more to it, but that kind of gives you a panoramic view of it.
What's fascinating to me is I love to consume content. I need to consume content. And whether it's articles, discussions, whether Facebook or Instagram or podcasts or magazines or whatever it is, and I see trends that are out there. Like you'd mentioned that guy who called you and said, hey, I've taken out 3 engines all the same way. And a lot of the conversations I have every week, I try to do it, is just to talk to different shop owners that I know I've gotten to know over the years and ask them how things are going. And so I can see two different parts of this. As I see the consumer, the truck owner, who has a frustrating situation where they're having the same failure multiple times, and it does get so heated and emotions are high when it is that work truck, daily driver vehicle that's needing an engine pulled 3 times or twice or 4 times. But then also that shop owner, where they're in that position as well. You mentioned some examples of yourself. Is, it's a big risk for them, and they get put in a very difficult position as well. And so when you were talking about these failures and things that can happen, is a couple things I really pulled from that. Is one, is if you're having the same failure, it could be other things, like you mentioned, the transmission, the tires, other things that are going on where, you could put your name behind an engine, install it, and 10 miles down the road, it does the same exact thing. And then also for the builders that are out there, is being able to verify, and we do take for granted that it's a new part, it's good to go. And there's going to be a certain amount of variance in just parts that aren't going to be exact. And how do you verify that? What are the processes you have? What are the tools that you have? How do you set yourself up for success? So I think with this topic and what we discussed, is it crosses and impacts so many people, whether we're the truck guy who doesn't understand anything about surface finish and hardness and all that stuff. We know what it's like if there's an issue and it's multiple times and our truck doesn't work, and we're losing money and we're getting frustrated. But then also for the guys who do know that stuff, and they're thinking, how do I verify what I'm putting together? How do I verify? Or if I'm buying something, how do I know it's been verified from start to finish? And so I think that's what's really important about this conversation in this episode.
Yeah. Well, I think the deceitful part of it is that people, some of the scary things I've seen that I didn't know, I didn't have enough sense to be scared of, how am I trying to say this? Success sometimes is your biggest enemy. It's not failure. Because in success, you don't learn anything, and you think because you got away with it, that you'll get away with it again and again and again, because you don't realize that there's a problem. So the guys that really know the most, sometimes are the guys that had the most, most failures on stuff, or the most problems on stuff, or have seen the many experiences, have had the many experiences as they come through the shop, and they've improved on that, or they've seen it with other shops or with other companies. And, in this business, you've got to get, if you're going to do it, you better use all the resources that you could possibly find, ask, read, whether it's AERA, PRA, if you're a production engineer builder or something like that, or, webinars, seminars, anything you can do to try to learn, because, you don't know you have a problem until you have the problem. I know that seems like a trite thing to say, but sometimes ignorance of something like that will allow you to go a little further and a little deeper in the hole, and you'll find out later that that it's a lot more painful when you've got these things that are coming up. So you taking this stuff, learning it, even from the stories or the examples that I'm giving. It may be a shop out there that's never had this failure, never had a problem, but I can promise you, if you stay at bat long enough, and it doesn't take very long before you'll have something like that bite you. I remember when I was starting out, I had this has been many, many years ago, that I had a machine shop that was doing all my work for me, and I built 10 engines with the machine shop. Out of the 10 engines that I had 2 of them that I had problems with. And one of them was a surface finish that we talked about on the cylinder walls, and the other one was the sleeve that got sucked into the block. Well, that's a 20% failure rate. That's if you're going to bat, maybe that's not that big an issue. If you can hit 800, that's fantastic for a major leaguer, but it doesn't work that way in our industry. you can't afford that kind of failure. 20% is way, way too high. So you're, as an engine builder, you're subjecting yourself to a machine shop and hoping and praying that that guy's doing the job that he said he's going to do, that he's going to pay enough attention. And another thing is he may very well not know this stuff. The biggest thing that screwed me up, and I hope people are still listening to this point, the biggest thing that screwed me up in this business was I was always taught to respect my elders. And, if an older guy's talking, you just shut up and you listen. And that's true, and I'm not taking anything away from that. But I had been hoodwinked before by listening to the guys that were older and that told me, oh, man, you're crazy. I've been doing this for 40 years, son. Just listen to me. And that guy's the guy that got me the worst because he's been doing it for 40 years. You can do something for 40 years and have absolutely no idea what you're doing. And I didn't think that was possible. But you can be bad at it for 40 years because you never learned from your mistakes or you never took accountability, responsibility for them, and you just let stuff go on. Just because a guy's been doing it for 40 years doesn't mean that he's a professional in what he does. Sometimes it can be that he's the biggest shyster of them all, and he's been doing it for 40 years. But I would put all my trust in this guy in this machine shop and say, okay, well, he's been doing it all this time. He says it's okay. I mean, this surface finish, I remember that one that I was telling you about, the surface finish was bad. A buddy of mine came over. He's a great mechanic, and I mentioned him before in other episodes, but he looked at that block, and he goes, man, that finish looks rough. It's like, yeah, but so-and-so said it was good. And he, I don't think I've run that. I was like, but he said it was good. Yeah, I don't think I've run that. And later on I got it together. I was like, when you told me that, yeah, I wish I hadn't ran that. And I was like, yeah, I tried to tell you. Yeah, but he told me he'd been doing it for 40 years. Who do I believe? Well, and the thing is that it boiled down to is what did it look like to you? Well, it looked like it was okay. It was okay. Well, if somebody said, okay, well, what needs to happen is your RVK needs to be this, your RPK needs to be this, your RK needs to be that. All right, let's check it with a profilometer. Well, then that gives me an authority instead of, it looks okay. I don't think it looks good. That's not a good scale. We need some quantitative values that we can put to the test and say, this is what it's supposed to be, and this is the parameters that it's supposed to operate in. And as I thought it was something I was interested I know you're a sports guy. Do you know, okay, I'm going to give you a little quiz here. Do you know who has the highest batting average of any Major League Baseball player? His batting average was 1,000.
It's probably a guy who had one at bat and got a single or something like that, but I don't know the name.
He did have one at bat. His name was Eddie Goodell, and he was 3'7", and it was a stunt that one of the managers brought in back in I think this was like 1950s or something like this, and they said his strike zone was about the size of a peanut, because the guy's 3'7". But sure enough, he holds the record for 1,000. He got, and they walked the guy, and they brought in a pitch runner for him afterwards. And I always thought that was funny. But there's a lot of application to that. The guy goes, well, I've never had those problems. I never had this issue. Well, you've never had an inch time at bat either. You take a guy that's been like, you take a Mickey Mantle that's been at bat. No, he doesn't have the same batting average as Eddie Goodell, but he's also been to bat a whole lot more, and he's, fantastic. But if you look at the stats on it, you go, well, this guy's a little better. No, you have to take into consideration the experience. So with shops, with the machine shops, make sure they've got the experience that with these particular engines. It's not as common knowledge as sometimes you might think. If a guy's just done 350 Chevrolet, he may be able to get away with things, maybe or maybe not, that he couldn't get away with on a Cummins build or a Duramax or a Power Stroke or whatever it might be. It's making, we might not consider big power, but what we consider big power now is not what we considered to be big power when these things were, 15 years ago or, whatever. And a tuner now can put, more havoc on these things. It's really important that you dot all your I's and cross your T's.
Yeah, especially as you think about it, starting out or being in business a little bit, and you need that job. You need that customer to drop off his truck, do the engine, excuse me, and you get it. And I think where it gets scary, or can be scary, is not the first couple jobs, but what about when you have 15 or 20 trucks out there? And what if you get that 20%, 30% comeback rate? It is a huge nightmare right now. And so it's, I know it's a challenge, for them, because you're wanting customers, wanting to keep the shop busy and stuff, but you just don't know. Are you going to get, 20 happy customers? You're going to get 10 that call you that are stuck on the side of the road. How do you accommodate that? What does it do to the rest of your business? So I think that part and what you mentioned and how this is so crucial, even though we're talking about lower engine failures, it applies to so many other things in diesel and in being a business owner in the automotive world. And so that it's a tremendous amount of value. And that's what I always love about these episodes is we go in with, an idea, something we're going to talk about. And it comes back to, you mentioned it on another episode, is how much everything is related, how much everything depends on itself. And so, this connects so much. So I appreciate you chatting with us today and getting us thinking about some things I know I definitely didn't. I didn't even know to even think about. So I was that guy that didn't worry because I didn't know I needed to worry. But there's a lot of tremendous information. So I appreciate your time today, Cass, and telling us about this.
Yeah, and like you said, it is, maybe it didn't help the guy today that is interested in building engines or never does that. But I get a lot of phone calls from shops, guys that are trying to get in their own business. And they ask me all the time, man, what advice could you give me? I'll tell you this, I nearly went out of business before I ever began in this industry. And the reason why, I told my wife, I said, I can't do this. I'm sick of it. Because I kept having this particular manufacturer that I was using for injectors. They were local, and I didn't realize. I just kept thinking, man, if this is the way that it's going to be, and I have to get 3 sets of injectors to get one good set, I can't make a living at this because I'm having to do this job over to the customer. I can't ask the customer to pay for that. It's not their fault. And not everybody's going to have a test stand to check an injector out. But there's certain things that I would do that I learned back then that I could possibly qualify that part. For instance, like let's say you had a 7.3 injector or something like that. And I'm just using this as an example because I want people to have always, whenever they listen to our podcasts, I want them to have some kind of takeaway and say, the engine building thing didn't apply to me, but, I am a shop owner and I did learn this from it. What I would do is if it was an injector with electronic coil, what I would do is I could verify at least the coil, maybe just plug the injector in and do a buzz test on it or something. That way at least I could verify, the coil is working. Because a lot of those injectors that I was getting, and eventually, I got smart enough to realize, this isn't the norm. That was when I first started in this industry a long time ago, and I just thought, well, maybe this is the norm. Maybe everybody, you don't know. I mean, you're getting into this thing. You have you don't know what to base it off of. You're just thinking, I'm very self-deprecating, and I'm always thinking, maybe it's something that I did. Maybe and I'm always putting the blame towards me. Well, in this instance, it wasn't. It was actually the manufacturer of the injector. But I was looking for ways that I could qualify the part. I didn't know the term of that, but ways that I could, as much as I could, qualify the part before I did the installation. If I get a injector, or if I get a turbo out of a box, when I was teching, I want to make sure that, do the small things. Make sure that the turbo will spin, inspect the part, look it over really good before you install it, because it will save you over the duration of your tenure as a mechanic. It'll save you thousands and thousands of dollars. The last thing you want to do is get to the very end of this thing and realize, oh, man, they sent something and FedEx dropped it, or something like that, and it's got a crack here or something. Inspect the heads. I made a comment or something. I was telling somebody, maybe it was, I don't remember. We were talking about qualifying cylinder heads and how you could do that with an airlift, and doing a vacuum on them. Just things like that will make your life so much easier. It'll make your bank account so much happier. It will make you get home at night at a decent hour sometimes. It will make your customers happier. It will make your employees happier because now you're not nearly as grumpy because you've got to redo this job or you got to pay that guy to do the job over again that's an employee. Think about how you can qualify the parts that you're installing. Now, some things just are visual inspections, but you know how many guys that I've seen go to install something and never visually really take the time to look it over good before they do, and they realize by the time they got it back together, oh no, this thing's got a big crack in it. I can't believe I didn't see that. Or, it's got this, that, or the other. You name it, the problem there. Taking your time and doing that. You're not looking, this may not be something that you have to have a micrometer with. It may not be something that you have to have a magnifying glass to see, but that'll save you a lot of headache, and that'll make you a lot more profitable, and it'll make you want to stay in the business, because nothing will make you want to get out of it quicker than when you can't make a living because other people, their failures are now you're having to, as a business owner, the thing that I've learned is you're having to take responsibility for all your employees as well as yourself. And you're also not only, it doesn't stop there. You have to take responsibility, unfortunately, for all your vendors as well, which stinks. And I hate that. And especially when you're an engine builder, and you go, that head gasket or whatever it might be, I didn't manufacture that, but it doesn't matter. I'm the one the guy wrote the check to, so I'm the one that has to take care of it. And, if you can do things you'd be amazed at our quality control list. It has become, it has become extremely thorough to the nth degree, and it's because of the responsibility placed on us from all these things that we're talking about. But yeah, it's a pleasure talking today, of course.
Don't forget, diesel fans, make sure and head on over to mishimoto.com. Check out what they have for products to cool your diesel truck down, and also universal products as well if you have a custom application. And if you're a shop owner out there looking to purchase Mishimoto products, just go to Turn 14 Distribution on any search engine. You can pull up their website, give them a call, chat with them, get set up, and get products heading to your shop and making sure your customers are back on the road as quickly as possible. Till next time, keep the shiny side up.